All right, so let's write today's date. It's 29th. So it's about sequences today. So arithmetic sequence. Now, what part of it we want to look at? You should be able to understand and identify if this sequence is arithmetic sequence, okay? We will, as much as possible, be able to, you must be able to differentiate between the position and the term of any sequence anyway, generally. So we'll be able to do that today. And solve simple question about finding the term or finding the term or position of a sequence. I think those three, and prove that a sequence is actually an arithmetic sequence. So I wouldn't want to go into the arithmetic mean yet. We'll probably do that when you come back next week. Arithmetic mean, then sum of AP, interesting stuff. So don't worry yet. It's an interesting topic we do in upper secondary, which you are part of now, more or less. Okay, so understand, okay, arithmetic sequences. Second thing I want us to be able to achieve is find term and position of such sequence. I want to be able to prove that a sequence is arithmetic. So I give you a question, for example, and I say, with this information, prove that the sequence is an arithmetic sequence. So, like I said, welcome to the world of proving. The world of baby math is over. Welcome to the big league. Big league. So I'll start by telling us what is an arithmetic sequence. We look at some important definition, very important definitions. Like what a sequence is, what is the notation of a sequence, and things like that. But let's go straight to the arithmetic one so we don't waste time. Now, an arithmetic sequence or a progression is the one, let me show you a definition that I have here, then I can explain. So look at the board, everybody. If you have a list of numbers, okay, or patterns, such that each term differ by a fixed number, okay, the gap is the same. The gap could be plus, the gap could be minus, okay, then you have an arithmetic sequence. Another way of, another name for this is the linear sequence, okay? And we can also call arithmetic sequence an arithmetic progression. That's where the word AP comes from. Again, if you have a sequence of numbers whereby the gap between consecutive terms, when I say consecutive terms, between 4 and 5, between 5 and 6, between 6 and 7, okay, between 100 and 101. Okay, I hope everybody's paying attention and no one is chatting privately with their friends. Okay, I need all attention, please. And you have a situation whereby between two consecutive terms, they are the same. Okay, the same ratio, the same number. I don't want to use ratio. Yeah, the same difference. Then we have an arithmetic sequence. That difference, because it is common to them, we call it the common difference. Okay? We call it the common difference because it's common to every consecutive. So on my screen, for example, I have Carter here, I have Yanko, I have Kinlon, I have Elsin, I have Giselle. If between me and Carter is the same number, between me and Yanko is the same number, between Yanko and Kinlon is the same number, then you say such number is common. And that difference is the number in question. It could be positive, it could be negative. So if the number is actually increasing, then that difference is a plus, right? But if the number is going down, that difference is a minus. So your common difference can be positive difference, can be negative difference. Okay, and it is common because it exists for any two consecutive terms in the sequence. Such a sequence is arithmetic. So how do you know as a layman? Do you have to keep subtracting? No, just look at the sequence. Is it plus something or minus? Remember what we did in lower school, maybe like Form 1 or P6. They call it term-to-term rule. Term-to-term rule is add 2, subtract 4. You remember that from P6 and Form 1, right? So this one where you have the term-to-term rule to be add something or subtract something, that is an AP. Okay, that's an arithmetic sequence. And that thing that you're adding or subtracting is that common difference, D. So this is a short thing I wanted to mention about arithmetic. So let's see what we need to write. Okay, you ready? If, okay, in a sequence, let's say if the terms consecutive of a sequence differ by same number, we have an arithmetic sequence also known as linear sequence or arithmetic progression, which is abbreviated as AP. Progression, that's double S. Okay. That number that it differ by is called the common difference. Okay. We use letter D to denote it. Small letter D. Okay. So basically, it is an arithmetic sequence if UN plus 1 minus UN is always D. All right. Now, what do we mean by UN? So For any sequence, actually. You have done n term before, so we're not going to waste time on what is n term. For any sequence, we use the symbol. We use any of the symbols. Any of this symbol for n term. Okay, we can use any of this.
Mr. Daniel, you're muted.
I don't know what happened. I got disconnected. Did you guys also get disconnected, or what did you see when I wasn't here?
No, you just disconnected. I'm pretty sure it's a school Wi-Fi.
And then
Yeah. So you saw me here, or what?
You
I think it's the school Wi-Fi. Hello, can you hear me? It says my internet is unstable. Can you hear me now?
Yes. Sometimes you cut out though.
Okay, how about now?
Now it's perfectly good.
All right, let's hope everything is fine. And everything I've written disappeared. Oh my God. Let's see. Are you serious? Nothing is saved.
I can send what you've written so far.
Did you have it?
Yeah, but like you wrote for any sequence, we can use any of the.
Okay, so that's what you have. Okay. Okay, so I'll begin with what is does everybody have it up to that point for any sequence?
yes.
Okay, so I'll just begin from that point. Okay. It's crazy. I hope this doesn't happen again. And I'm not sure if I have internet cable port on this laptop. No, I don't. So I'm gonna have to rely on Wi-Fi. Oh yeah. So annoying. Okay. So I'm going to introduce about 3 to 4 symbols for the n term. So I'm just going to continue from that point here. Okay. So for any sequence, you can use the symbol or any of the symbols. The symbol. So sometimes you see TN, sometimes TN, sometimes UN, sometimes a small letter U, small letter N, to represent nth term. Okay, right. UN, AN. Okay, AN is better. Yes, UN and UN are like the same, so let's just take one of them. UN, AN, to denote nth term. Okay, I'm sure we are familiar with n term. So something like n term, okay, is equal to maybe 3n plus 1. Remember this? So instead of writing n term, we could just say un equals 3n plus 1. So you should know that the question is talking about n term. Or some question says tn is equal to 3n plus 1. So if you're talking about the 5th term, it will be t5. All right? Or it could be an is equal to 3n plus 1. So if I'm talking about the 11th term, then I say a11 equals 3 times 11 plus 5, sometimes plus 1. Okay? So these are just symbols that you might find in books. Okay? And questions. Maybe you are trying to solve some IB question next year. So don't be surprised. Oh, what is TN? What is AN? Oh, in our class we did UN. So what does AN mean? What does Tn mean? It's the same thing, it's just notation. That's the point I'm trying to make here. Okay, that's the point I'm trying to make here. So with this, if you use a curly bracket and the symbol for n term, we are talking about the sequence generated by this. For example, if I have Tn equals maybe 2n plus 1, let's use that. What are the terms? What are the terms in this sequence? Quickly. 3,
5, 7, yeah, 9.
These are the terms, right? So rather than listing all these terms, I could just say this is a sequence. Everything here is here. Okay? Everything, this means all this. Okay? So that's the next point I want to make before I go to. This is just some form of awareness. So the main, we will do more of calculation throughout next class, but today we will mix calculation with notation. Okay? Okay. The symbol. Okay, that symbol represents a sequence generated by the nth term, which is un. So when you see that curly bracket, it's a sequence. What you have inside the curly bracket is the nth term. Okay? So e.g., if I have 2n plus maybe 5, okay, this represents the sequence. When n is 1, we have 7. When n is 2, we have 9. When n is 3, you have 11, 13, 15, and so on. So instead of writing all this, we could just write the n term and we put it in a curly bracket. So I want you to be aware of that. Are we ready? Okay, so what about the n term that we want to look at today? The general term, sorry, about the AP that we want to look at today. The general term of an AP is what we really want to look at today. We'll look at the arithmetic mean later, okay? Okay, so now for arithmetic, so n term, now we have discussed n term, so now let's talk about the n term of an AP, which is the main point of discussion for today. No. Okay, I'm gonna save this just in case of another stuff in terms of AP. AP means what? Anybody remember?
Arithmetic progression.
That's a progression. So which means a linear sequence, right? We call it a linear sequence because the equation is in linear form. Okay, the n term is always in linear form. And that is what assures you that you have plus or minus. Usually, remember the coefficient of n is that number you add, right? Remember that? So it's just an extension of your IGCSE syllabus, basically. But now we are calling them names. Not like in a negative way, calling people names now. Okay. So we want to discuss the n term of an AP. Now, we will normally use U1 for the first term or letter A. So letter A is very common. If you come across U1 also, it means the first term. So if the first term is A and the common difference is D, let's work something out ourselves. I want to write a sequence. The first term is A. The common difference is D, so which means D is being added, right? I need attention, please. Then which means the second term will be A plus D, right? It means D will also be added. Then the third term will be A plus 2D. Do you agree? Another D will be added. Then the next term will be A plus 3D, okay? Now this is term 1. This is the first term, the second term, the third term, the fourth term. Compare this position. Now these terms are the values of n. Compare this position to the coefficient of D. What do you notice? Anyone? Quickly.
I think I see, but I don't.
Yeah, just say it. So if I want to find the nth term, what will it be?
DN.
Think again.
The coefficient of D plus 1.
Coefficient of D plus 1. So can you tell me how to write it in terms of A and D now? Come on, we have a lot of people in the class. I only hear from Justin and Candy. I'm sure others can hear me.
A plus n minus 1 times D.
When it was fourth, you have 3. That's 4 minus 1. For the third term, you have 2. That's 3 minus 1. For the second term, you have 1. That is 2 minus 1. For the first term, you have 0. This is 0D. And that's 1 minus 1. So for the nth term, it will be n minus 1. Does that make sense? Okay. So the nth term of an AP, okay, with A as first term, D as common difference, D as common difference is UN equals A plus n minus 1 into D. Okay, so let's take note of that. So this is the nth term of our AP. Okay, and I want to ask a question now. Okay, let's see. If there are, what can anybody say about the last term of an AP? Last term of an AP. If you know the end of the sequence, how can you find the last term? Anyone? If I give you A, okay, for example, the first term of the AP is 3, the common difference is 2, and there are 21 terms in the AP. How do you find the last term? Anybody? How do you find the last term? I didn't see what is it.
You substitute like 20.
Yes, Anson? Anson, yeah?
Substitute 21 to UN and then 3 to like.
So tell me what to write. Tell me what to write. A is 3, D is 2, and there are 21 terms in the AP. I want to find the last term. Quickly, I have 6 more minutes. You're on the right track. I just need you to tell me how to do it.
Oh, you write UN equals like 3 plus 21 minus 1 and then times 2.
Say that again.
UN equals to 3 plus 21 minus 1 and then times 2.
So basically, you are using the n term formula also. And that makes sense. N term is just like saying someone. Someone could be the last person on the list. It's also someone, right? This is nth term, some term. And now it is the last term, the last person. This is saying somebody. This is the last of those somebody. So if this is for nth term means any term, then it also should work for this one as well. Does that make sense? So the n term formula can also be used for the last term. The only difference is, remember, n is the position here. So in this case of nth term, I should say where n is the position of terms. Okay, n is the position of a term, of the term. No, maybe not, maybe of the term. So it doesn't look like a. Okay, n is the position. So if you're talking about the first term, you will do, it won't happen, you won't believe what just happened. I wanted to clean this part of the board and I'm looking for something to clean it, as if I'm still working on the whiteboard. So for example, if the first term is 7, the common difference is -2, okay, then we can find U1. U1 is just A, that's 7. We can find U6. U6 will be A is 7, n minus 1 will be 6 minus 1, D is -2. And that is 7, 5 minus 2. 7 minus 10, which is -3. Yeah? Something like that. So this is how our UN is used. Okay? Now, your last term is also an unknown term. Okay? Also, since last term is a term in the sequence, so we can say last term L, I use small l for that, is also A plus n minus 1 into D. The only difference is that your n this time around is not a position. What do you think n should stand for here? Anyone? Quickly, please. If I'm talking about last term, what will n stand for this time? Any idea?
The last
One of the last term?
The position of the last
This
one.
is the last one.
Not really. So, well, it means the position of the last term. So this time around, n will be the number of terms in the AP. The number of terms in the AP is the position of the last one, isn't it? If 10 people are on a queue, the position of the last person determines the number of people on the queue. Okay? 10 people are on a queue. The position of the 10th position tells you there are 10 people altogether because the number 10 person is the last person. So when you have a question, no one is going to tell you, find the last term if the position of the last term is 21. No. You probably get something like, find the last term if there are 21 terms in the sequence. So 21 terms in the sequence means the last term is 21st. The position of the last term is 21st. Am I making sense, everybody? Just wanted to clear that. So n in this case can be seen as the number of terms in the AP. Okay, number of terms. This n will be useful later, especially when we discuss the sum of AP. All right, this n will be useful later when we do that. So this is just some kind of a preamble on like introduction on how to find AP, blah, 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 and things like that. Anyways, now I will give you some questions to practice on your own. I will send you an example in the WeChat group. Let me share that with you now. Then I close the meeting. Then we can do more when we come back. So look at this. Okay. Consider, I don't think the self-taught is, okay, it's working. Okay, let me play this for you quickly. Okay, please tell me if you can hear the sound once I start playing it.
An arithmetic sequence is a sequence in which each term differs from the previous one by the same fixed number, called the common difference. For the given sequence, the second term minus the first term is 7. The third term minus the second term is 7. And we continue this process for all of the terms we have been given. In each case, one term differs from the previous term by 7. We assume that this pattern will continue indefinitely, so we conclude the sequence is arithmetic. The first term is 2, and the common difference is 7. To obtain the nth term,
let me add more to that. The reason it is an arithmetic sequence is because we can identify a common difference. So when there's a question to show that something is an arithmetic sequence, you are actually to show that there is a common difference between them. The difference between them is common. That's the only condition. So this 7 being common is what shows that it's an arithmetic sequence. All right? And the sequence is with first term this and common difference that. But if you just show this and say, oh, the difference, since the difference is the same, then the sequence is arithmetic. That's enough. You don't have to write it exactly like this. I hope you understand my point. Hello?
Yeah.
All right. Okay, quickly.
of an arithmetic sequence. We start with the first term, u1, and then add n minus 1 lots of the common difference d. For example, notice that we add 1 lot of the common difference to get u2, 2 lots of the common difference to get u3, and 3 lots of the common difference to get u4. We substitute the first term u1 and the common difference d and simplify to give an expression for the nth term. To find the 100...
Again, the question here is find the general term for the nth term. What you have on the board is for every arithmetic sequence. Okay, this is for any arithmetic sequence with any A and any D. The example you are looking at is for a specific arithmetic progression. Wave your hand if you understand what I mean by that. Good. Wave your hand, please, if you understand what I mean by that. All right. So what you have on the board is for all arithmetic sequence. But what you're having in this example is for this particular arithmetic sequence. This particular arithmetic sequence, we know the first term, we know the common difference. But in your formula that we have written in our book, we don't know the formula, we don't know the common difference. We are saying for any A, for any D. All right? And what was worked here just now is not necessary. I'm talking about this. This is not necessary in your workings. This is what we had already done. Remember, Candy and I think it was Ansin who later answered the question that n minus 1. So this is what we have done. This is just to explain. So when the question asks you for the arithmetic sequence of a particular, for the general term, which is n term of a particular sequence that is already given, we are saying get an expression like this. Substitute the A and the D. This is A in our own case, and the D, and simplify. That's all. Okay, that's all you have to do.
To find the 100th term, we substitute n equals 100 into the expression for the nth term.
So you don't start from the beginning, because you already have the nth term for this particular sequence. You just substitute directly into it. Okay, quickly.
The 100th term is the first term plus 99 lots of the common difference. To determine whether a number is a term in the sequence, we look for an nth term, which is that number.
So if you want to know if this is a term, when I substitute any number, will I get 288? We just solve the equation and see which one makes sense.
In part 1, this gives a linear equation which we solve for n. The solution is the positive integer 119. This tells us that 828 is the 119th term of the sequence. In part 2, we again have a linear equation. The solution is 335 and 1/7, which is not an integer. This tells us that 2341 is not a term in the sequence.
Remember, n has to be the position, right? It makes sense to say this is the position of this number in the sequence is 119. It doesn't make sense to say the position is a fraction. That's how you disqualify the other one. Does that make sense, guys? Okay, so I will share this with you. I'll send you a picture of this so you can write in your note as example. I'll share that with you now. Oh my God, I'm so late. From 4, here we go. Then later I will send questions that you need to do. I'll pick some questions from here and you will try that, okay? See you next time. See you on Monday.
Bye-bye.
Bye-bye.
Bye.